Good afternoon, ladies and gentlemen. Welcome today to Integrated Science, looking at making predictions for types of chemical reactions. So I know that we kind of introduced this thing on Friday. Some of you are struggling with some things, and I want to try to help in this process. So the first thing that you're going to need to do is to determine the types of chemical reactions first, and use then that sheet to be able to help you make the predictions of the products. So as we go through this list here, this first one, right? Here we've got an element, we have an element plus a compound. And if you can visualize that, right, you've got one thing here on the left-hand side of our reactants makes this a single displacement reaction. This next one here is looking at, now you've got a compound, iron, oxygen, hydrogen is a compound, plus nitrogen, hydrogen, and phosphorus. That's a compound. So you have a compound plus a compound, that's a double displacement reaction. Now for this next one here, right, silver oxide, AgO, that's a compound, right? You can just write C there, but you've only got one reactant. And when you only have one reactant, remember you're going to have now a decomposition reaction. And this last one here, this is an element plus an element. And so therefore, when we have an element plus an element, we're going to be putting the two things together. The other kind of clue to this part would be the fact that there's only going to be one product over there, and this is then a synthesis reaction. Now, I do know that I told you that one of the things that you might want to do then is to start trying to identify then charges, which really does kind of help in this process. So one of the things that you might want to do, the next step that you might want to do here is just write your charges up here. +1, +3, -2. Now in a single displacement reaction, what we're going to be doing then is we're going to be exchanging the positives. And so if you want to, just go ahead and do this then. So we're going to make that change then. Now, the one thing that you're hopefully going to be able to see in this, and one of the things that it says on that sheet is don't take subscripts with balance for charge. Well, how do you know what subscripts balance for charge? Well, if you write the charges up there, hopefully it makes it a little bit easier, right? This 2 is the balancing for the sulfate, right? And this 3 is balancing there for the Al. So that means you don't end up taking those. And so we're not going to take the 2 and the 3 when we crisscross or when we move them back over for our products. So if we're going to exchange our positives, our products now become Al plus, and now we're going to put NaSO4. And just put the products together. Don't worry about the charge. Now, what I would probably do is still put the charges up above, right? +3, +1, -2. And now what do you have to do then for balancing the charges? So +1, -2, I've got to crisscross and put the 2 to there. There's technically already a 1 next to the 4 there. The last thing that you need to do is you need to balance the whole equation for quantity then. So 1 sodium, 2 sodiums, 2 sodiums. 2 aluminums, 2 aluminums. 3 SO4s, 3 SO4s, but now that changes my sodiums to 6, so I will go back and change my sodiums then to 6. Okay? So if you can follow those steps, I think that really does help. So after you've, and let's go to the next one, let's try this again. So once you've identified the equation, write down the charges up above. Okay, so this 2 is balancing for a charge, so this is +2, hydroxide's -1. Ammonium is +1. Phosphide is -3. So in a double displacement reaction, what we're going to do is we're going to exchange the positives. So I'm going to take the 2 and the 1, and I'm going to exchange the positives. And then go ahead and rewrite. Don't worry about charges just quite yet, so go ahead and rewrite. So I'm going to end up with then NH4OH plus FeP. Now, what you might want to do then is to go ahead and rewrite the charges back up above what you just did over here. So we've got a +1, a -1, which is a +2, that's a -3. So you're going to need to do, we don't need to do any crisscrossing with ammoniums and hydroxides, but we do need to do a crisscross with the iron and the phosphates. So I'm going to bring this 3 to here, this 2 to here. And then from there, I can get it to balance then. So with that, then we got to balance the whole equation going across then. And so again, balancing for quantity then. 3 ammoniums, 3 ammoniums. I now have 2 hydroxides, I now have 3 hydroxides. I need 3
Bill
ions.
Smith, please call 4404. Bill Smith, please call 4404.
Put the 3 there, and that now makes 6 hydroxides. So if I put a 6 here, now I've got that. I need 2 phosphates, so there's my 2 phosphates, and I now have 6 ammoniums as well. So I think the biggest key that you guys need to be able to do is to write the charges up above the reactants and then do the things accordingly. Now for this decomposition reaction, right, we're going to break this down into its individual parts. And so really what that means is we're going to make silver plus oxygen, right? Remember, oxygen's got to sit by itself, so it needs to double. That balances it for its charge, basically. And now we need to balance the whole equation. Those are our 2 products then. We don't need to worry about the charge of silver because it's by itself then. So we've got 2 silvers, 2 silvers then. Now the last part then that we need to do then in the synthesis reaction is to build these together then. So we're going to take Mg plus N to make MgN. Now, charges will come into play in this one because we're making now a new ionic compound with this. And so here's a +2, this is a -3, and we're going to need to crisscross 3 and 2. And with that, then we need to balance the whole thing. So 3 magnesiums, 2 nitrides, 2 nitrides. And now we've balanced the whole thing then for quantity. Oh, I forgot to balance this one up here. O2, 2, and that makes this a 4 then. I apologize, forgot to do that. So I think the big thing that you guys need to really take a look at is how do you then make your predictions of your products. If you write the charges down first in the reactants and then be able to determine whether or not you're adding them together, you're exchanging positives in a single displacement or a double displacement, you can then predict your products. Go ahead and just write the new compounds down. Then the next part would be to write the charges above the products and then crisscross for charge and then balance the whole equation for quantity. So I hope that that really helps. If we take a look at the next page then, and let's just kind of look at one as an example here again in this one. Let's just take a look here at number 5, right? The first thing we're going to do is we're going to determine the type of reaction. So here's our element plus compound, and that is going to be then a single displacement reaction. The next thing that I would do is I would write my charges up here, +2. This is +1, -1. Now go ahead and write, remember we're going to exchange the positives, so we're going to draw that little line there. And then the next thing we're going to do is we're going to just write the products. So I get an Ag plus ZnNO3. Now what you may want to do then is go ahead and write the charges back up here. Well, this is +1 and that's fine because it's by itself. This is a +2, that's a -1. And so one of the things again that I would do is make sure you need to crisscross. So the 1 comes to the Zn, the 2 is going to come out here, but we need to put that in parentheses then, and then balance the whole equation then across for quantity. So we've got 2 NO3s, 2 NO3s, 2 Ags, 2 Ags. And that would be the process then for doing that. So when you take a look at that, just again, I think the biggest thing that's going to help you in this part is writing down the charges up on top of the reactants and then writing down the charges of the products, making the new products, balancing for charge, and then balancing the whole equation itself. Okay, so good luck with that for today. Again, what I'd like you to do is to finish up with this page here. This is page 92. I'd like you to do is to finish this one for today, and we're going to correct it at the end of the hour. Thank you very much. We'll see ya.